So I'm Kelly de Koninck, a recent hire at EfficientIP. I have a background in telecom, but I recently switched to the vendor market. And today we're going to talk about zero trust and how DNS can fit in that. Are you already presenting the slide? Yes, thank you. Yeah, next slide. So our agenda for today is as follows. We're going to start with the basics of zero trust and see how DNS fits in that. Then we are going to talk about using DNS as a security layer between users and applications, allowing you to see traffic, to analyze traffic, and to filter traffic. And we'll finish with a practical example of two use cases, one showing how access control works and one showing you how you can control your IoT. Next slide. So let's start with a quick look at how zero trust foundations work and how DNS fits in that. Next slide. The concept of zero trust architecture was popularized by Forrester, the analyst firm, probably well known. It's not really a product or a feature, but it's a framework that describes the architectural components and required technologies in a world where you can no longer define whether a device or a user is secure just based on perimeter alone. There are three things you need to consider for your zero trust strategy. You need to granular visibility over events on your network, ideally down to the level of individual clients. You should perform analytics on traffic in real time to check the behavior or the usage for each client. And you want to automate the configuration of your network and security systems so you can include the entire infrastructure. Next slide. Let's now talk about how we add a very important security layer to protect users, applications, and data on your network. Next slide. Let's start by explaining where DNS fits in networks. Pretty much every connection starts with a DNS lookup. DNS is a mission-critical service, and it links the user to both internal and external applications. DNS makes sure that applications find the correct routing for their traffic. So in short, we can say no DNS simply means no business. DNS is a perfect example of something that no one cares about until it doesn't do what it's supposed to do anymore. And then everyone knows that DNS is there. Next slide. So because everything goes through DNS, you can use it as a first line of defense for protecting your network. Because virtually all network connections are initiated using DNS, and therefore DNS has visibility over most IP traffic before it even starts. It therefore provides you valuable information, including client ID, which allows to behavioral threat detection. So even if not primarily seen like that, DNS can also be an important component of network security. And because it sees threats as the earliest point in the traffic flow, it should really be used as your first line of defense. Next slide. The next component DNS brings is the analytics capability, which will help you detect and prevent threats in real time. In order to efficiently protect against DNS-based threats, you need to analyze DNS transactions from the source to the destination. This is where EfficientIP offers a unique solution that combines threat intelligence based on destination domains and behavioral attacks detection because we analyze clients' traffic in real time. Client-based behavioral threat detection will identify most advanced attacks such as DNS tunneling, phantom attacks, and also data exfiltration using the DNS protocol, which is more and more common. A standard security solution, such as a next-generation firewall, only offers a limited peripheral traffic visibility. And if you use external DNS services rather than a solution like we offer, they typically only see a part of the DNS traffic, not the traffic that is cached locally by your own servers. So we prevent and we block attacks with threat intelligence based on destination requests. Because most malware, phishing, and ransomware use malicious domain names for the command and control. The EfficientIP solution analyzes the requested domain's reputation and proactively blocks all communication with external malicious servers. We have real-time threat intelligence using reputation data feeds, for instance, of anti-phishing and anti-malware, so we are sure that we offer protection against new attacks. And we offer application access control by filtering DNS requests at the client level, so you can distinguish between groups of clients down to the individual client, and that is pretty unique actually, between internal and external applications, and of course also based on internet categories like most do. Next slide. DNS provides valuable data which can be fed to other security systems, such as a SIEM. The objective is to bridge security silos and to deliver an automated end-to-end control. And sharing these security events will help you improve detection, both in speed and in accuracy. It will prevent spread of attacks and it will accelerate remediation. And it helps you to enforce security policies on different layers. Next slide. So let's conclude by revisiting the 3 basic principles of Zero Trust and how DNS can help. First of all, DNS offers early visibility over traffic intent, so it is ideally placed as your first line of defense. Secondly, by performing real-time analytics on user behavior and making use of DNS filtering, you can considerably improve control over which users can access which apps. And lastly, sharing the data to security systems will help you automate security responses and simplify threat remediation for your SOC. Next slide. Let's now have a look at how we can actually improve application access control. Next slide. Yes. Effective Zero Trust requires control of which devices can access which apps, domains, and services. And to do that, authentication is often used. It checks on logins and passwords, but it might already be too late because at that time, the user is already on the portal, which leaves the door open for malware. Blacklisting DNS applied by firewalls is usually a one for all, and it allows you to create just one group containing all clients. They can either access DNS or they can't. But ideally, you want to limit the access for specific devices only, while allowing other devices to just pass the control and use DNS like they are supposed to. Doing that using a firewall is very complex to set up and especially to maintain. So if you want to add granularity, you need to go down to the client level for applying filtering, or what we call microsegmentation. Next slide. This microsegmentation can be provided at the DNS level by not only applying filtering policies based on destination domains, but also based on clients. We call this feature client query filtering, or CQF. What CQF brings is the unique capability to simplify creation and management of multiple client groups, and then to allow separate filtering policies to be applied to each group. This is how the solution works. First, groups of clients are created. Then lists of domains are created. And client groups and domain lists are populated through the DNS standard service, the zone. We then apply filtering policies based on client identification, the fact that the client is in a group, basically, and we map that to a domain request. And if a client is in a group which is associated with a list of forbidden domains, the request is blocked. The benefit of this DNS-based client access control is that it adds an important security barrier to reduce risk of exposure down to the individual client. And of course, we can now combine domain filtering with client filtering, so many new use cases can be introduced by enterprises and by service providers. What this basically means on this slide is, if a device can access DNS, it doesn't automatically mean that it can do anything on DNS. And this is a unique feature. This is not something a firewall can typically offer. Let's now take a look at a couple of examples. Go to the next slide. In this first use case, we want to apply filtering policies to a specific group of clients. Multiple clients, groups, and domains lists are created. Next slide. One more click. Okay. The default group of users is allowed to get access to any application. Next slide. The list of red clients should not be allowed access to specific applications, and they are listed in a deny list. So if a DNS request comes from a client, red client, it is analyzed, and if the request of the application is not in the domain list, the traffic is authorized. Next slide. We skipped one, actually. Yeah, so we're already at the second use case. We skipped one with the animation, I guess, but basically what the previous slide should have illustrated is that if you have a red client, which is under analysis, if it has a request that is allowed to pass, of course, we'll simply pass a DNS request. If it is in the red zone, if it is a client, or if it is a domain name that should not be passed through, we filter it, even though that client has access to DNS. So we have to provide access to the DNS for that client, but we can still distinguish between what it can access and what it cannot. We're now at the second use case, where we want to control access for IoT devices, preventing them to be used as attack vectors, for example. And we do this again by creating multiple client lists and allow lists. Go to the next slide. Yes. Leveraging the full DDI solution, a standard laptop device is authorized by default. Next slide. When an IoT device is detected by the DHCP service, DDI automation will update the IPAM repository, so we know that it is an IoT device, and it will automatically update the client DNS list of IoT. So you do not have to do that manually, of course. Next slide. Any DNS requests from an IoT device is then screened, and an authorized application is, of course, allowed. Next one. But if any other request is coming in, which is denied, we will block it. We will not provide a response on DNS. So we protect the application, basically. Next slide. So as a summary, there are 3 key things to remember from this session. First of all, DNS sees virtually all traffic, so it's ideally placed to be the first line of defense for your networks. Secondly, by making use of client query filtering, this will help you improve the access control to your vital applications and infrastructure. And combining DNS-based user behavior traffic analysis with threat intelligence will definitely make your zero trust strategy more effective. I will leave you with a recap of these benefits, and I will now hand over to my colleague, Norman.
Thank you very much, Kelly. Thanks to everybody for listening to that. If you can switch next slide, please. So just, I will talk briefly about EfficientIP as a company in brief. So EfficientIP has been established since over 15 years. The company is headquartered in Paris, and we have all our R&D there. We also have offices in North America, in APAC, in Middle East. Our headquarters in North America is in Philadelphia, in APAC in Singapore. We cover today about 110 countries, and we have more than 1,000 customers. Our business around DDI, so DNS, DHCP, and IP management, is really around network automation and security. So we have unique differentiators there. In terms of network automation, we can typically automate every single steps of the DDI components. And as far as security, we have unique differentiators where we can detect ransomware at the DNS level, or we can detect phishing attacks, we can detect APT, and we can see APT attacks forging months before they are really known, just because of behavior analysis. We can also identify whenever DNS is used for exfiltrating data. One of the easiest way today to exfiltrate data after a breach is done is through DNS, and 60% of the exfiltration is done through DNS. And it's very, very hard to control, and we can detect this type of things. So we have a lot of benefits around those features. And on top of that, we provide a lot of functionality around resiliency because we can manage a very large amount of traffic. So we're not 20 or 30% faster than competition, but 20 times faster. And that's also a reason why many operators adopted our solution. And you might not know about it, but you are probably already using our solution by being customers of other companies. If you can go to next slide. Here we have a few of our references. We work with any vertical, higher education, healthcare, finance, industry, and you probably are already using our solution whenever you watch a movie on Netflix, whenever you buy online from IKEA, or you connect to internet through Orange, through Bouygues Telecom, through SFR, through Post in Luxembourg, you're already using our service. So thanks again to everybody for your attention, and Adi.